So today's lesson is about logarithms and logarithmic functions. And we're actually not even going to get to the function part. We're just going to do logarithms. We're going to learn what logarithms are. We've been talking about inverses, how you take squared and undo squared with a square root. Those are inverse operations. We've been graphing inverses, like how do you graph an inverse function? If you know the first function, how would you graph the inverse point? How would you do it?
You would swap y and x.
Just switching your x and y?
Undo on operations.
Right. And it always reflects over the y equals x line. So then we were talking about exponential functions, but we haven't learned about inverse for exponential functions. And the inverse of an exponential function is a logarithmic function. So we're going to first just practice some logarithm properties, and then we'll actually do graphs with them too. We have some space. We're going to take some good notes. I'm color coding things. Okay, if you look at b to the x, b is the what? Base. B is the base. And x is the exponent. All of them are variables right now. So b is the base and x is the exponent. When we rewrite this in logarithmic form, we're going to write log and the log always has a base, which we're going to write as a low subscript number, and that base is the base from the first equation. The next thing that gets written is y, and then equal sign x. When this first example is written in logarithmic form, the base is this little number on the log always. Base. Always. And the log expression always equals the exponent. Always equals the exponent. The log equals the exponent. The log always equals the exponent. We have this swirly method when you go between forms. The swirly method is a gimmick. It is a trick, but it doesn't really teach you what these values are. I really feel like if you want to understand this stuff, you need to know that that is the base and that is the exponent of the original form. But there is a swirly method, which I'll show you. You just need a gimmick. You always start with the base. Then you go to x, and then you go over to y. This is b to the x equals y. That's what that is. B to the x equals y. So I can do the swirly method on this side too. Start with log base b of y equals x. It's the same direction. It's what direction is this? Counterclockwise. I couldn't think. But the swirly method goes the same direction for both. B to the x equals y, or log base b of y equals x. So it goes the same way. If you want to use the swirly gimmick method, that's fine. Again, the base is the little number. It always equals the exponent. So rewrite each equation in exponential form. When I look at this, I read this as log base 2 of 16 equals 4. Log base 2 of 16. So what is my base? 2. Log always equals the exponent. So what is my exponent? 4. And then equal sign 16. So with the swirly method, 2 to the 4th equals 16. Is 2 to the 4th 16? Right, that makes sense. So the next one. What is my base? 4. What is my exponent? To the 0 equals 1. 4 to the 0 equals 1. Anything with 0 power equals 1. I see some of you are working ahead. That's excellent. So the next one is 12 to the 1st equals 12. Is that true? Why does it always have to make extra marks? Does that annoy you as much as it annoys me? Okay, the last one, just be careful. A few of you, I saw, Rick, something there, but you didn't quite have enough information on your paper. What's my base? And then 1/4 is to the -1, but I got to tell anybody that is using this equation that all of 1/4 is to the -1. Meaning parentheses equals 4. Otherwise, it's only going to take the first number to the -1. It's like if you typed it in your calculator. All right, pretty easy. You just have to understand that these are inverse operations. We can rewrite them. All right, now we're going to go the other way. We're going to start with exponential, and we're going to rewrite it into logarithmic form. So I'm going to start with the word log. It's always log base b. So I need to know what the base is. 5. And then that is of 25, and it always equals the exponent. Log always equals the exponent. So I know that the 2 goes on the other side of the equal sign. You could do the swirly method again. Log base 5 of 25 equals 2. So the next one is going to be log base what? 10. Oh, you're in the yeah, that's fine. 0.1 equals -1. Again, the swirly method, if you're doing it that way, log base 10 of 0.1 equals -1. Then we've got log base what base?
It's 8.
It is an 8. And then you put 4 equals 2/3. It always equals the exponent. And then the last one we do log base 6 of 1 over 216 equals -3. Always equals the exponent. If you're not sure which number goes where and you didn't remember the swirling method, then it always equals the exponent. The base is always base. Now, on question B, I actually would not have written it that way. I would have written this as log 0.1 equals -1. Because when the base is 10, it is common. It is something that we use logs very often that are in base 10. We use them so often that log without a base written there is automatically known that it is base 10. So if you see something that says log 0.1 equals -1, you should know that that base is 10. They're just not going to write it. So that's what the next little section is on your paper is common logarithm. If I have log base 10 of x, that is the same thing as writing log of x. You just don't write base 10. I have an example of somewhere else where there's a number that we don't write, but everybody knows what it means. Just, this is not really has to do with this, it's just other things that we've done. Do you know what to do for this?
Square root.
You do square root. But all the other roots, we have to put a number for. But this one you automatically know is square root. Because it's so common that this one's always square. Even though there's not a 2 there. So it's kind of like that, where this is always log base 10. This other one, natural logarithms, this is log base e of x. But we never write log base e because it's so common. It actually gets its own special symbol. It gets ln of x. So log base e is the exact same thing as ln. It is the natural log. That's what ln stands for. Yes, because it's the natural, e is the natural base, yeah. Yeah, totally. So when we go to evaluate means find one value. So it's like a number. Find the value. And we're going to do log base 4 of 64. Why do you guys have your calculator?
Find a new spot. I found it.
You found one. Oh, yeah. So you're going to have to do this by hand. And you're going to have to prove to me why it is the answer is 3. So let me give you an example of how I would do this. I would think that log base 4 of 64 equals some number. That's what I'm trying to find. I'm trying to find what it equals. And I'm not really that familiar with logs, so I'm going to change it to exponential form. I'm going to use the swirl method, or I'm going to use 4 is the base, x is the exponent, equals 64. And then I'm going to use the knowledge that I got in chapter 5 to say 4 to the what power is 64.
4 times 4.
So the answer is 3. Now the answer is not x equals 3, because I did not say solve for x. I said evaluate, so we're just finding the number. I put the x in myself. That wasn't in the original question. So my answer is just 3. There are other ways of doing this. That is just one way of doing it. I'm actually going to show you another way in a couple examples. I'll show you another way of doing this too. All right, how about the next one? We've got log base 5 of something, 5 to the something equals 0.2. Now, 0.2 is a decimal, so I'm going to make it into a fraction instead to make it a little bit easier to think about. 5 to the x is what? 1/5.
Oh.
So then I have to think, what power can I take 5 to that makes it 1 over 5? That makes it a reciprocal.
-1.
-1 would be the answer for this one. 5 to the -1. Remember, negative exponent flips it. Reciprocate. This next one is 1/5 for the base. So I'm going to write it as 1/5 to something equals 125. Now if it's 1 over 5, and then when I raise it to that power, it's now like a big number. What's something that you think is special about that exponent? What do you think?
It's got to be a -1 to flip it.
It has to be a negative to flip it. But if I flip it, it's going to be 5. It's not going to be 125. So now how do I make it 125 after I flip it, Aaron? Third power. So my exponent should be -3. 1/5 to the -3. And if you're not participating, you're not going to remember this stuff. And if I give this to you on a non-calculator section like I did on the last test, you're not going to know how to do it. That happened on the last test. No matter how many times I said, you have to do this without the calculator. You need to do this without the calculator. Okay, last one. We've got 36 to some power equals 6. So we have to figure out what exponent is going to take 36 into 6. Is there something you know about 36 and 6? Square root.
The square root of 36 is 6, so that's 0.5.
Right. 0.5, or there's another way, yeah.
Could you do 1/2 for the exponent?
Remember, the exponent is the same as square root 36. And that was on your test. It wasn't 36, it was 81. But that was on your test. So some of us didn't know what to do when we had an exponent, or an exponent of this fraction. Okay, so the answer is 1/2. So if you didn't know it last chapter, we still need to make sure we're asking questions and learn it now, because you're seeing it over and over again. All right, what is next? Oh, evaluating common and natural logarithms. So question A is to do log 8. You see this and you say, what base is that? It's not written there. And it's base 10. If it's not written there, it's base 10. But it's so common, it actually has its own button on your calculator. There's a log button. So you hit log, you type in the log button, and then you hit 8. Enter. What? You would need to close it if you're doing stuff after you did the log of something. You should get 0.903. Approximately. Approximately.
Swap up, though.
Yeah, it's on that first column. See it? Yeah. Okay, the next question is a lot the same. It is a ln 0.3, but since the natural log is so common, it got its own button on your calculator. So you just use the ln button and then type in 0.3. It's negative something.
Negative 1.2.
204.
Hello.
We have to round correctly, right? We should round correctly, right? There's a 9 after it. We're gonna round it up. If you didn't get that on your calculator just now, you should ask, like, hey, Miss Griswold, I'm not getting this. Come see me. Uh-oh, I should plug in. My computer. What do you guys think? Probably a good idea.
I think you guys mean that you know what the process is.
All right, we are almost done. I'm skipping the student practices for now, because we will come back to. And using inverse properties is the last section that we're going to do today. And then we'll finish the rest tomorrow. Using inverse properties. Before we do this, let me give you an example of something that you've done before. Okay, we did this in the last chapter. If you take the cube root of 8 squared, or you take the cube root of 8 and then square it, you're still getting the same answer. What is 8 squared? And what's the cube root of 64?
You just write that as the 2/3 exponent.
Yeah, you could do it that way too. I mean, there's multiple ways you could do it. This would be cube root of 8 and then squared. So either way, we're getting the same answer of 4, right? Oh yeah, do it that way if that helps you. What you notice is we've got our squared in 2 different locations. We've got our cube roots kind of in 2 different locations when we look at where the squared is. So let me show you one more. If I do the square root of 9 squared, I do the square root of 9 squared, that's the same thing as the square root of 9 squared. And what happens to the square root in the square? What happens to the square root and the square? They don't just go away. What do? They cancel each other out because they're inverse operations.
Yeah.
So with logs, there are inverse operations. The log itself, log base b, is an inverse operation of base b. So I'm going to write what they have. I'm just writing it a little bit bigger so I can explain it. When they have log base b, and we have the base b with some exponent, log base b and base b are inverse operations. Log base b and base b cancel each other out. So we get x. We cancel out log base b and the base b. We get x. Over here is another example, just in a different format. If we have base b, and then in the exponent is log base b, okay. So if we have base b, and in the exponent, log base b, they cancel each other out, and we just get x, what else is in there. So these are inverse operations, and they undo each other. So if I'm going to simplify question A, 10 to the log 4. What base is this log? It's not written, but we know it is 10. And if I have 10 for my base, and then in my exponent I have log base 10, these cancel each other out. What is the answer to question A? Right. And then for question B, we've got log base 5, and then we have 25 to the x. I cannot cancel out log base 5 with 25, but I can rewrite 25 as what? 5 to the second. Right? 25 is 5 squared. So I can rewrite that. And if I rewrite that, I do have an x out here, but what happens when I have power to a power? What do I actually do to the exponent? And multiply them. So I have log base 5 of 5 to the 2x. And if you see log base 5 and then a big 5, what happens to them? They're inverses, they cancel. What is my answer? 2x. Turn the page or some student practice. Take 4 questions.
Remember, basically, that if you see a number for the base, you see it's squared. If you don't know how high you go, you can just take that root of it.
Yeah, you're just going to rewrite it with that exponent, yeah. So the answer to question 13 is what? It's x, because the big base 8 and the exponent of log base 8 cancel out. This next one is a little tricky to read. That's the answer. This says log base 7 of big 7 to the negative 3x, where negative 3x is the exponent on the 7. So the log base 7 and then the base of 7 undo each other, and we get negative 3x. And the next one, we have log base 2, but that is not a big 2. Can we make it a big 2?
Yeah, 2 to the 6.
64 is 2 to the 6. So I can rewrite this as log base 2 of 2 to the 6x. So my answer is 6x. Log base 2 and the 2 cancel. This one? What is LN?
Uh,
I didn't write
the actual one is the-
Remember, ln is the same thing as log base e. So if I have e to the log base e, 20, then I get 20. All right, your assignment is in the book. And I have books in the class. Remember, you can get to the book through Big Ideas. You can take a picture of the book. It is, I think it's through 315 though. I think if you're going to take a picture of it, it's 2 pages. And you have some time to start. It's like 12 minutes, 11 minutes to start now. So there should be 5 books sitting over there unless somebody already grabbed some of them. Yep, there's 5 books over there. And then I've got unlimited books under here. Unlimited, yeah.
It's up there.
It's 17 to 24 all.
Why are you trying to read a little?
It says all. It says all. Yeah. I'll put it back up.